look at using proportional relationships. And the first thing we're going to talk about is this ratio. So if the similarity ratio of two similar figures is A over B, then the ratio of their perimeters is A over B. Okay, so which is the same thing, right? So the similarity ratio is the same as the ratio of the perimeters. Okay, the similarity ratio equals the ratio of the perimeters. Okay, and then it says the ratio of their areas is A squared over B squared, or the whole fraction squared. Okay, so the similarity ratio squared equals the ratio of area or the perimeter ratio squared. Equals the ratio of the areas. Okay, so if you know what the similarity ratio is, and remember that's just like side to side, a ratio of one side to another side, it's the same as the perimeter, and then the area is going to be squared. All right, and now we have this graphic organizer for similar figures. Okay, so here's an example of two similar figures, okay, that appear to be rectangularish in shape. Okay, so a side of 2 to 3 and then a side of 4 to 6. So if I compared the shorter sides of both of those shapes, I would have 4 over 2. That would be a ratio of the two sides, or 2 over 1. Or I could also compare the smaller figure to the larger figure, which would be 1 over 2. Okay, usually what we use first is the one that appears first, or in the question it'll say compare the smaller to the larger or the larger to the smaller. So it just depends on the wording for what you know you have to do first. Okay, which means the ratio of the perimeters would be 1/2 or 2 over 1. Okay, and then Avery, if we know what the ratio of the perimeters are, how can we find the ratio of the area? Multiply by what?
I don't know.
Oh, well,
multiply by what?
Yeah, multiply. You said multiply to multiply them. Multiply them by what?
Each other? I don't know. What do you mean multiply by what? I thought you times those two together or something.
What two together?
2 and 3 on the area of the rectangle.
Oh. Okay, yeah, and that would be 6, right? And 4 times 6 would be
24.
okay, 24. So you could do that and you could reduce it. Yeah, so you could find the areas and then set up the ratio. Okay, what's another way you could do it? Tony, you know?
Square the fraction.
Okay, so let's double check and make sure that that works, right? If you squared 1/2, you would square the top and square the bottom. What's 1 squared? 1. 2 squared is 4. So it'll be 1/4 or 2 over 1. So I just wrote that out. If I did 1 squared over 2 squared, it would be 1/4. Or if I did 2 over 1 squared. Okay, either way you write this, you're going to be squaring the top and the bottom. Now, if I had 6 over 24, does that reduce to 1/4? 6 over 24? 6 goes into both, right? Yeah. Yeah? Okay, so With this one, if you had 6/3, because this one I compared the smaller sides, if I compared the larger sides, notice that it's still the same thing. It's still 2/1 or 1/2. So it doesn't matter what sides you take as long as they are corresponding. Okay, as long as those are corresponding sides. Okay, any questions for me so far? Alright, now example 2, solving for a dimension. So we are going to have several story problems, so we're just going to go over a couple of strategies and how to work our way through these. Okay, so one thing I do is I use a highlighter to just highlight important parts. So you have a Wisconsin road map. Kristen measured a distance of 11 1/8 inches from Madison to Wausau, I hope. The scale of this map is 1 inch corresponds to 13 miles. Okay, remember that's another way that you can write your ratio. What is the actual distance between Madison and Wausau to the nearest mile? So we are trying to find the actual distance. And then notice it says to the nearest mile, so we're going to be doing some rounding here. Okay, so the similarity ratio of map to actual is 1 inch for every 13 miles. Sorry, I do have my semicolon there. It's kind of hard to see. Okay, so 1 inch to 13 miles. So what I can do is I can set up a proportion. Okay, do you guys think you can set up your own proportion? There's actually a couple of different ways you can set it up. Right? Several correct ways you can set it up. Okay, so why don't you take a second right now if you haven't already and try to write that down. Okay, Carson, what are you thinking for this? How'd you start your proportion?
So the 1/13.
Okay, good. So 1 inch over 13 miles. And then were you able to set that equal to something?
11 and 1/8 over X.
Good. 11 inches over X amount of miles. Okay, good. And then, Xavier, what method do I use to solve this proportion?
Cross multiply.
Right. So that means I'm multiplying 1 times X, which is just going to be X. And then 13 times 11 and 1/8. Okay, and then when I plug this in, I like to turn it into an improper fraction. So like if I do 8 times 11, what do I get? 88. So then this would be 89 over 8. So when you're multiplying that together, if you do 13 times 89, that's the top, 1,157, divided by the bottom, which is 8. And then that's going to be approximately 144.625. So this says to the nearest mile, which means if I have 0.6, that's going to round it up. And X will be approximately 145 miles. Bless you. All right, now let's look at our next story problem. So Lady Liberty holds a tablet in her left hand. The tablet is 7.19 meters long, 14.4 meters wide. If you made a scale drawing using the scale of 1 centimeter to 0.75 meters, what would be the dimensions to the nearest tenth? so what would be the dimensions? And then we're going to round that to the nearest tenth. Okay, so the first thing we're going to look at is the similarity ratio. Okay, so the similarity ratio of the scale to the actual is 1 centimeter for every 0.75 meters. Now what we have to do is find the dimensions, which means we have to find the length and the width. So what I want you to do is set up a proportion for the length and the width. And I'm going to come around and check just to see how you guys are doing. See how we did. Caitlin, will you tell me what you set up for the length?
I did 7.19 over x, and then it's equal to 0.75 over 1.
Oh yeah, good. Okay, and I did something different, which was the same thing. So I started with the ratio of the actual. And then what Caitlin said is she started with 7.19 over x equals 0.75 over 1. That's exactly right. And it doesn't matter which way you do it, you're going to end up with the same equation as long as they are equivalent. So you get 0.75x equals 7.19. And then you would have to divide both sides by 0.75. Okay, and then, Caitlin, what did you get when you solved this?
Approximately 9.6.
Good. Yep, so be 9.6 centimeters long. When you divide, you get 9.58, and then the 6 is repeating, which will round to 9.6. All right, and then Logan, can you tell me what you set up for the width?
Took 1 divided by 0.75, and that times it by 4.14.
Well, you didn't multiply it, right? Did you set up your proportion?
No, I just multiplied it.
Oh, okay. So you said that you did 1 times what?
I took 1 divided by 0.75 and made 1.33 repeating, and then I times it by 5 point, or
4.14. Okay. So you're just doing everything at one time, right?
yeah.
Okay, so if you cross multiply, you will get the 4.14 equals 0.75x, and then you will divide by that. Okay, and then what did you get for x?
5.5.
Good. Okay, so x would be 5.5 centimeters wide. Okay, so then your dimensions are 9 by 6 by 5.5 centimeters. All right. Our next example is going to be with triangles. So we're going to use the ratios to find the perimeters and the areas. You are given that the two triangles are similar, which right away we know, Riley, if the triangles are similar, what's something we know about them? Okay, good. So we know that the sides are proportional. And then Grace, what's something else we know if the triangles are similar? The angles are equal. Yep, the same. Okay, so the sides are proportional and then the angles are going to be the exact same. So we're going to find the perimeter P and the area A of triangle QRS. So first let's start with the similarity ratio. And remember, the similarity ratio is just going to be two corresponding sides. And they already give you one pair of corresponding sides. So this is going to be 13 over 9.1, and they're both in centimeters. Okay, now notice that you're also given the perimeter of one of the triangles. Sorry, I know it's kind of small. Okay, so you can see that the perimeter is 36 centimeters in one of your triangles. So the perimeter of triangle LMN is 36 centimeters. And we can use the similarity ratio to find the perimeter of triangle QRS. Okay, so then let's try to set that one up. When I am setting up mine, I just like to stick with one on the top and one on the bottom. And I chose to use LMN measurements on the top and QRS on the bottom. So I know that the similarity ratio, because remember, this was from triangle LMN, this was from triangle QRS, so I need to stick with that pattern. Okay, I can't say 13 to 9.1 and then start with QRS, because then it would be flipped. Okay, so whatever you start with here, that's what you want to start with in this ratio as well. So it'll be 13 over 9.1, and then the perimeter that I found was for triangle LMN, which is why I have to put 36 on the top and X on the bottom. Okay, if your similarity ratio here was 9.1 over 13, then you would just flip these. And then, of course, we cross multiply to solve. Okay, so we'd have 13 times X equals 36 times 9.1. And then we would divide both sides by 13. Okay, and then you should get approximately 25.2. Okay, Okay, and it says to find the perimeter of QRS. So that's 25.2 centimeters. Now what we have to do is find the what? Area. Okay, so we're finding the perimeter and we're finding the area. Find the perimeter and area of QRS. Do you guys think you have an idea on what we have to do first? To find the area? Mm-hmm.
Well, I figured that these triangles are isosceles.
Okay,
That so the other side, MN, is 13.
but do we know that for sure?
No, but I was just assuming.
Can't assume. Yeah.
I did the same proportion, but for 36 I did 60 instead.
Why did you do 60? Oh, yeah. Okay, so you did 60 because of this, but and then you used 13 over 9.1.
Yes.
Okay, so we have to change that.
Oh, 'cause it's
Yes. Okay, so with the area, you have to take the ratio and do what to it? Square it. Okay, so to find the area, we need to use the similarity ratio squared. Okay, which means if we have 13 over 9.1 squared, okay, let's find out what that would equal. So 13 squared is what? 169. Okay, and then 9.1 squared is going to be
82.8.
good. Okay, so now what we can do is set up our proportion. So our proportion is going to be 169 over 82.81. And then like Caitlin said, you're going to use 60. And that's because they tell you that the area of LMN is 60. So we're going to do 60 over x, and then we're going to cross multiply. Okay, so when I do this in my calculator, I'll do the 82.81 multiplied by 60 first. Okay, and then I'll divide that value by 169, and you should get about 29.4, which means when I'm labeling this, the area is going to be in what units? Units squared. So it's 29.4 centimeters squared. Because it's the area. Okay, so for 7.5, we're doing page 491. 7 through 12, 15 through 19, 24 through 26, and you're going to finish your 7.5